Hello, I'm going to work on solving equations today. So the first thing that's important for you to understand when we're solving equations is that we always are trying to keep things equal. Equation means an equal sentence in mathematics, if you like. So our key vocabulary over here, we've got equation. That's like the mathematical sentence with an equal sign in it. An expression is probably what you'll have on either side of your equation. So it might be something like 2x plus 4 or 3x minus 5 or 4x squared plus 2x minus 3. They're mathematical expressions. And then a term is the individual bit. So it might be 3b or 4x or 5y. And they're what make up those expressions and those equations. Okay? When we're looking at solving equations, because we have that equal sign in the middle, we need to think of it, that equal sign is like a balance scale. And if I do something to one side of my equation, in order to keep it working, in order to keep it equal, I have to do the same thing to the other side. So just like with a set of scales, if I put on a letter X over there, if I just did that, it would stop being well balanced and it would bend down, wouldn't it, and tip to one side. I'd have to put an X onto that side as well to keep it balanced. Okay, let's have a look at an equation or two and hopefully that'll make some more sense. So we're going to start with single step equations. If you already know how to do these, you can always fast forward through the video. But a single step equation, and then we'll move up to two steps and more complicated equations from there. But a single step equation is something like x plus 2 equals 6. Now, when I've been teaching this topic in previous years, one thing I notice quite often is that students will go, it's 4. They haven't really thought about what they've done. And so sometimes, even though you might be tempted to fast forward this video, it might be worth you having a little think and a little watch of this bit too, to see how we do it. Because if you can instinctively see that the answer is 4, but don't do your working out, you're not learning how to do the working out ready for another time. And that means that when we get to the more complicated equations, you find them harder. So stick with me perhaps. Let's see how we go. Over here I've got x, my term, my number, my variable, my unknown. And I've got that variable and I've got 2. And I know what 2 is. It's worth 2. It's always worth 2. It's never going to change. It's just 2. And I've added them together. If I wanted to undo that, if I wanted to have just my value on its own, then I'm going to have to get rid of that plus 2. And I always say, what do we want? X by itself. When do we want it? Now. We want that X all by itself on that side of the equation. And that plus 2 is in the way. So how can we get rid of adding 2? We can do the opposite, the inverse. The mathematical opposite is called the inverse. We can do the inverse of adding 2, which is taking 2 away. Now remember, our balance scale said if I do something to one side of my equation, I have to do it to the other side, otherwise things go wrong. If I took something off of a set of scales from this side, it would go up, wouldn't it? I need to do the same thing to the other side. So just like on my balance scales, because my equal sign is like my pivot point, my balance point, if I take 2 from this side of my equation, from my left-hand side, I've got to take away 2 from my right-hand side of my equation as well. X plus 2, take 2. If I've added 2 and then taken it away, I've only got X. I've done what I wanted to. I've got X by itself. If I've got the 6 and I take away the 2, I end up with the 4. So just like you knew it is 4, I'm not saying it's wrong, but now you know why, because we've done the inverse of what happened to begin with. That's how we do single step equations. Let's have one more practice of a single step equation, but a different type this time. This time let's have 3 lots of x is equal to 12. 3x means 3 times x, or 3 lots of x. So we've essentially done some multiplication over here. To get our x by itself, we're going to have to do the inverse of that. We're going to have to do the mathematical opposite. So if we have multiplied by 3, the inverse of that is going to be dividing by 3. And if I divide one side of my equation by 3, I have to do the same to the other side. So 3 lots of x divided by 3, 3 times something divided by 3 lots of something is going to give us just that number on its own. And 12 divided by 3, coincidentally, I've made it equal to 4 again. So in this expression, in this equation, we've got the expression 2x plus 4. We have 2 things to do, 2 steps that we've got to follow. And then we've got our answer on the other side of the equation. So, when we're looking at these, you will have heard of BIDMAS previously. When we use BIDMAS, we always follow it. Our brackets, then our indices or powers or orders, then our division, multiplication, addition and subtraction. When we're writing these equations, that's the order that things have happened in. If we want to unravel that, we kind of have to do the BIDMAS backwards. We kind of have to start with the subtraction and the addition, then the multiplication, division, powers, and then the brackets. We have to do it backwards because we're going in reverse order. That's the mathematical way to look at it. But sometimes it's easy to see with an expression like 2x plus 4, the plus 4 bit's kind of the easiest bit to break off like a stick of rock, isn't it? Just break off the end. The 2x, that 2 is very closely stuck to the x. So the first thing we're going to do, like I say, taking our BIDMAS backwards, we haven't got any subtraction, but we have got an addition. So we're going to do the opposite of that addition first. We're going to break off that plus 4. To get rid of plus 4 from this side of our equation, we are going to do the inverse. We're going to subtract 4. And if I subtract 4 from that side of my equation, I have to subtract 4 from this side of the equation. I have to keep it all balanced. It's very important. So 2x plus 4, take away 4, we're left with just 2x. I keep my equal signs lined up. 10 take away 4 is 6. Now I'm left with a single step equation, and I know that I've got 2 lots of x over here, but I only want x by itself. How do I get from 2 lots of something to 1 lot of something? I do the inverse of multiplying, I divide. Divide that side by 2, so I have to divide this side by 2 as well. 6 divided by 2, in this case, x is 3. The first thing I've got that I'm going to get rid of is my take away 5. And I've got to do the inverse of that, so I'm going to add 5. If I add 5 to that side of the equation, I have to add 5 to this side of the equation. 3x take away 5, add 5, I'm left with just 3x. 13 add 5, I've got 18. Then I have my 3x equal to 18. To get from 3x to just x, I've got to divide by 3. If I divide that side by 3, you guessed it, this side has to be as well. So we end up with x equal to 6. Let's try one with a division. Let's have x divided by 2 plus 4 equals 8. People often panic when there are fractions involved or divisions involved, but you mustn't worry. In this case, you can see that the division is just over the x, so you mustn't worry too much. The plus 4 is still going to be the easiest thing to get rid of. So we're going to subtract 4 from both sides, leaving us with x divided by 2 equal to 4. To get rid of dividing by 2, we're going to multiply by 2. If we do it to that side, we have 2 to this side. we're left with x equal to 8. Let me show you how this would be different if we'd had that x plus 4 that had all been divided by 2. These are different equations. You can see here it's just the x that's been divided by 2. That's why that division line is only under the x. Over here, the whole of that expression, x plus 4, has all been divided by 2. And that's why that line goes all the way underneath that whole expression, those numbers and terms. So, in this case, the first thing we want to do is get rid of the division because it's dividing the whole of that side by 2. And it makes it very tricky to deal with the x plus 4 because we've got the 4 being divided by 2. So the first thing we're going to do is multiply that side by 2 and get rid of that fraction. That then leaves us with x plus 4 equal to 16. Now we can deal with the plus 4. We can take it away, doing the same to the other side as well. So it leaves us with x equal to 12. Okay, let's move on and have a look at some very complicated equations. This is where it gets really tricky, and where if you had been somebody that tended to use your brain and just seeing the answers and not really sure what you were doing, this is where you tend to get a little bit stuck. In these expressions and equations, what we're going to have is x's, or variables, unknowns, on both sides of our equation. So it'll look like something like, let's have 5 lots of x plus 2 being equal to 3 lots of x, just trying to think, plus 10. Let's have those as an example. Okay, now in this equation you can see it's much trickier because we've got these unknown variables on both sides of our equation. And that tends to make it a little bit trickier. We can't just look at it and go, oh, x must be 4, or x must be 7, or x must be 12. We've actually got to really think about it and work out what's going on. What we want is all of our x's by themselves on one side of the equation and all of our numbers on the other side of the equation. And the easiest way we can do that is by a bit more balancing. How about if we say that, well, we've got 5 lots of x over here, that's more than we've got on this side, there's only 3 lots of x over here. Let's take those 3x and get rid of them from both sides, so that we're just keeping the x's on the side we've got the most of them. So I'm going to take away 3x from both sides because I really don't want any x's, any variables on the right hand side of my equation if I can help it. So 5x plus 2 take away 3x, or 5x take 3x, because we do all the like terms together, all the same things that are the same, like terms, they're common, they're the same as each other. 5x take 3x is 2x, plus 2, that's not a like term, it's different than the 5x or the 3x, it's got no value of x with it, so it's just plus 2. And that's going to be equal to 3x take 3x is nothing, we've got rid of all of them, just 10 now. All of a sudden, that equation looks so much nicer because we've got it just like we had it before for the two-step equations, all of our variables on one side, and we can sort our numbers out in a moment. I want to subtract my 2, doing the inverse of adding it, again, to both sides. 2x then is equal to 8. Now I know that I can divide both sides by 2 to get x all by itself. And look at that, I've made x 4 again. I hope that's been helpful.